Alright guys, today we're going to talk about ratios in similar polygons. So similar polygons are kind of piggyback on our congruent polygons. So the first thing we'll do is we'll define similar. Now this is going to be your notation for similar, just a little squiggly mark. And they're figures that have the same shape but not necessarily the same size. So in order to show that triangle 1 is similar to triangle 2, we're going to go through a process, and how you're going to write it up is triangle 1, and this would be your similar mark, is and triangle 1 is similar to triangle 2. Okay, notice that they have the same shape, but not the same size, and we'll talk about how you know that's similar in just a second. In order to say something's not similar, you'll just put a little X through it. Notice that they're both triangles, but they're not the same shape, so they can't be similar because of the fact that they're not the same shape. So our definition for similar polygons is that their corresponding angles are congruent. That's your first checkpoint right there. And their corresponding side lengths are proportional. Okay, this is where we're going to linger a little bit. So if you guys check out our two polygons here, you'll notice these guys are similar because of the fact that all the angles are congruent, and they went through and wrote all the angles being congruent, the corresponding angles. So remember, you have to match them up, and that's going to be an important thing to carry through from last semester for us for this lesson. And notice they wrote polygon ABCD is similar to polygon EFGH. Notice A matches with E, B matches with F, etc., etc. Okay? The second part is dealing with our proportions. And remember, a ratio is just a comparison. You're going to write it as fractions. You've written it as fractions, as colons. You can even use the word 2 when you're comparing something. But for this, we're going to write it as fractions. Basically, when you put the corresponding sides, for example, AB over EF, that's going to simplify to 1/2. If I put another corresponding side over the side that it corresponds with in the similar polygon, it's also going to simplify to 1/2, etc., etc. Now, it doesn't matter. Here we put the small over the large. You also could put the large over the small. You're still going to get the same number. It's just going to be flipped. Either way, it doesn't matter as long as you keep it consistent. So what we're going to do here is just go through and show and use that definition and show that these two guys are similar. All right, so here you can see angle R is congruent to angle Z. We're just going to write that up. Angle R is congruent to angle Z. All right, we also know that angle Q and angle Y are congruent. And then by our third angles theorem, we know that angle S is congruent to angle X. So we got our first checkpoint taken care of. All of our angles are congruent. Now we need to go through and we need to show that all the sides are proportionate. It doesn't matter, again, if you make these your numerator or this your numerator, as long as you're consistent with how you write your proportionate. But what we're trying to do is we're trying to find the same number it simplifies to every single time. All right? So here I know that YZ corresponds to QR. Notice how Y matches with Q. So YZ over QR is going to be 12 over 18, the side lengths, which simplifies to 2 over 3. Okay? Now let's go through and check out another side. We're hoping 2 over 3 pops out for the next side as well. So I have that XZ corresponds to SR. So that's 9 over 13.5, and that also simplifies to 2 over 3. And then our final side is going to be XY in that order, and that corresponds to SQ. So XY is 6, SQ is 9, and that simplifies to 2 over 3. So the fact that we showed that all of our angles are congruent and all of our sides are proportional, that shows that these two polygons are similar. These two triangles specifically are similar. So I want you guys to go ahead and pause the tape. This is going to be your notes quiz on Monday when I see y'all again. So we went through and showed all the sides are going to be, all the angles are congruent. Okay, so because this is 59 and this is 90, this is 59 and 90, these two guys have to be congruent as well. And then let's go through and show that all the sides are proportional. So AB is proportionate to JG, which is 10 over 5, which simplifies to 2. All right. And then we also have CB and HG. Which is going to be 6 over 3, and that simplifies to 2 as well. And then our final guy is going to be AC and JH. Which is 11.6 and 5.8, which simplifies to 2. So we checked both boxes. We showed that the angles are congruent, and we showed that the sides are proportionate. If you prefer to switch these and get 1 over 2, 1 over 2, 1 over 2, that's perfectly fine. Alright guys, so the second thing that we're going to do is we're going to talk about a similarity ratio. And your similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So basically, if you guys go to our example here, triangle ABC is similar to triangle EFD. In that case, it doesn't matter because all the angles are congruent, all the sides are congruent. But if you put AB is similar to ED, you're going to get 3 over 6. All right, that's your similarity ratio because they're all going to simplify to 1/2. Or if you put ED over AB, it's going to simplify to 2. So either of these are going to be your similarity ratio. What we found here on this slide is 2. 2 is your similarity ratio for that example. Okay? This is important right here. I started. I've already talked about it a lot, but let's just make sure we're crystal clear. Writing a similarity statement is like writing a congruent statement. Be sure to list the corresponding vertices in the same order. Okay, so you guys need to make sure you're matching up. That's something we were very particular when we did our proofs, so stay particular with that. Okay, so we want to determine whether the polygons are similar. If so, write the similarity ratio. So we want to say basically what it simplifies to in a similarity statement. So we'll see what that looks like. Okay. So these are rectangles, so let's go ahead and fill in what we know. This is going to be 12, of course, opposite sides are going to be congruent, and that's going to be 4. This is going to be 16, and this is going to be 6. We also know that these are all going to be right angles because they're rectangles. So we know that all the corresponding angles are congruent. Okay, we checked that first piece of the definition. All right. However, are all of the sides or the corresponding sides proportional? Well, let's look and see. PS over TW is going to be 4 over 6, and that simplifies to 2 over 3. Okay? And then we are looking for a 2 over 3 when we do our other side. So SR over WV, these two pieces right here, are 12 over 16. Well, that's going to simplify to 3 over 4. Because of the fact that you don't have the same ratio when it simplifies, that means that no, these are not similar. Okay, so let's see a counterexample to that one. And we'll get into writing a similarity statement for this. So we know that angle A is congruent to angle D, all right? We also know that angle B is congruent to E, and then again, by our third angles theorem, we can say that C and F are congruent. Okay, so we have all angles are congruent. We checked that box. Now, we need to see if the corresponding sides are proportional. And this is the one that takes a little bit of time. And that's basically our question mark. Okay, so let's look at our corresponding sides here. We have 16 over 12. And that simplifies to 4 over 3. Okay, so we got that guy taken care of. And then we have 24 over 18. And that also simplifies to 4 over 3. So this is looking good. And then our last one is going to be 20 over 15. Which again simplifies to 4 over 3. So your answer to this question is yes, these triangles are going to be similar, okay? your similarity ratio is going to be 4 over 3. Okay, so that's one of the pieces of information that we wanted to write down. And then here's going to be your similarity statement. Triangle ABC is similar, okay, what does A match up with? D, to triangle D. What does C match up with? F. And what does B match up with? E. So D, E, F. And this is going to be important, guys, okay? Now, one other thing I want to make a point of is, how did I know that 16 went with 12? Well, look at the fact that A and C go together, D and F go together, okay? So that's something to pay particular attention to as well. Because if you put 16 over 18, you're not going to get the correct similarity ratio, but it's because 16 side AC is not similar to side, or is not corresponding to side EF. AC is corresponding to DF. So that's something to be particular about when you're working these. All right, guys. So I want you to take a second and pause the tape. And actually, you know what? We're going to skip over this and we're going to keep moving. Okay, I want to get this last example in. So a railroad boxcar can be used to transport auto parts. If the length of the actual boxcar is 50 feet, this is a model, so your length of your actual boxcar is 50 feet, find the width of the actual boxcar. Okay, so we're going to set up a proportion. We want to show that these guys are similar. They're obviously going to have the congruent angles, and saying to the nearest tenth of a foot. Okay? So basically, we're going to compare our length to our length and our width to our width. Our length to our length, and our width to our width. Okay? So 50 is proportionate to 7 because those are corresponding sides. And x is proportionate to 2. Do your cross multiplying, and you end up getting 7x equals 100, and divide, and x is going to be 14.3 feet. So even though these guys are in different you don't have to worry about converting it. Okay, guys, so here you'll notice here we have our boxcar and our model, It's going to be set up similarly. Okay, so 9 is going to coincide with 1.25, and 36.25 is going to coincide with x. So this is going to be your homework that we're going to work in class on Monday. And I hope that y'all had a great break.